Okay, good morning. Welcome back to my YouTube channel. Again, this is your host, Santos Capillan Jr. Needless to say, always wishing you a good day. Guys, today what I'm going to do is to create a video tutorial or the part 2 of my cold room air coolers thermostat. Okay, guys. So this will be how are we going to software integrate this thermostat to our BMS or our building management system. Now, first, to be able to see some information in this thermostat, we need to connect it to our existing MSTP network. Okay, if you are watching my tutorial, I have created MSTP port or a network, okay, intended for my third-party system. Because in my automation server, okay, wait a minute, let me show you again let me show you my automation server. Okay, so this is my automation server. Now let's see if I can zoom a little more. Okay. Now my automation server, as I said, I have created another MSTP network. Okay. So as you can see here, I have here my RS485. I have my communication A and communication B. Now for my communication A, I'm dedicating it to my backnet controllers. Okay. So these backnet controllers are B3 devices. Now for communication B, I will dedicate this for software integration of those third-party system. When I said third-party system, actually, if you are a BMS engineer or a solution provider, first you need to study the project specification or the BMS specification. Okay. Then out of this specification or out of your study, you will try to recommend the backnet controllers. If you are going to use backnet controllers, these backnet controllers, based on your study, will be the one to handle all the control and monitoring of HVAC equipment, electrical, and low current system. Okay, so this will be your uh, controllers which you are supplying. Okay, so now for the third party system, like let's say if it is a warehouse, like my previous project, that is a warehouse, then the room or cold room air coolers, they are going to bring. I mean, the supplier of the air coolers, they will be the one to supply the thermostat, just like what I'm having now. So they will be the one to supply it. So meaning the BMS solution provider will not be the one to supply it. So we can consider that one as a third party. I hope you get my point. Okay. So this thermostat, uh, of course, you have to coordinate. Okay, you have to coordinate with the mechanical supply. You have to tell them, okay, you have to supply something that I can easily integrate with my BMS. Okay, so meaning you can recommend, okay, I'm using BACnet MSTP. Maybe you can supply a thermostat that is capable of communicating with that communication protocol. So they have to conform with that one. Okay. Now maybe you will say, okay, if you have an IP device or backnet over IP, then you can supply it also. Now, if your automation server is capable of communicating with LAN devices, then you can also ask for that one. But nowadays, the most commonly used are backnet over MSTP. Okay? So today, what I'm going to do is to show you how are you going to do the software integration for this thermostat. As I said, this communication port B, okay, this is my MSTP or RS485 port. So I'm dedicating COM-B for my backnet MSTP third-party devices, just like my thermostat. Okay, so this is my automation server. Again, automation server is very powerful. It's just like the network controller in between, because the upstream or the downstream or the up level, it is capable of communicating to your enterprise server. Then down below, it is capable of communicating to, let's say you have a COM-A here for backnet controllers like my B3 devices based on my previous tutorials. Then for third-party system like this thermostat, DADs, let's say chiller plant manager, which is also working in MSTP. Okay, so this is a very powerful like a network controller. Okay, so let me go back to my system so that we can start the software integration. Okay. So guys, this is my system. Now this is my automation server. Now this is representing my automation server, just like what I have shown you a while ago. Okay. Now in my automation server, once you connected the thermostat in the MSTP network, I already show you how are you going to do it in my part 1. Then you can go to your automation server. Okay, so automation server. Then here you can see this is my automation server. So I have a list view. Okay, right now this is the list view. Device discovery. So I can discover devices, date and time. Okay, so this tab will show you the date and time communication. Okay, so this is the communication, default communication properties. Okay. No, anyway, I don't need to discuss these tabs. I need to show you how are you going to uh, do the software integration. Okay. Now in device discovery, once it is connected, the thermostat, and it is powered up. Okay. That once again, be careful in doing the power connection and the communication connection in the thermostat. Okay. So don't make any mistake. Okay. So you can what is the selection here? We have here automation server IO bus. If you have an IO bus or separate IO bus, backnet devices, iNet devices, lone wolves. Now, as you can see, these are the supported devices that can be discovered automatically from our automation server. So I want to discover a backnet device. Okay, as you can see, it will display all the network that you have created. Now I have created the network tree which is intended for my third-party system. Now, as you can see, I removed already my VAD because I have done the software integration for that one. I've shown you already, okay? Now, so this is the AC one. Actually, this is the backnet name for the AC for this thermostat. So it is AC1, okay? By default, that will be the backnet name. Now, we will see why it's not communicating. Let me see. Let me check. Okay, maybe the communication port is removed. Because as you can see, it is offline. Okay, so let me refresh. Keep on refreshing it. Wait a minute. Just let me check my MSTP connection because it stopped communicating to my automation server. Okay, sorry guys, I have to check the MSTP cable connected to my thermostat. Now it's on already online. Okay. So let me go back to my what I'm trying to discuss. Okay, from this device discovery, all you need to do is select the backnet devices. Okay, then make sure the device is a backnet supporting backnet communication. Okay, now as you can see now my uh, AC1 is already online. When it is not online, you will see some red marking here, then an X. Okay, so you can let's see if we can get some information from this. Actually, I changed the baud rate to a lower one. Okay. Now, anyway, I have seen these points. Okay. Now, guys, once you try to double click this backnet device, then it will try to show you what are the information exposed. Okay. When I say exposed, these are the information exposed to our system. Okay. So as we can see here, there are so many information here. Now actually, if you will try to see, let's see, okay. So here we have the dirty filter. Okay, so meaning it can also uh, monitor if the air cooler fans having a filter. Okay, so it can also monitor the status of the air filter if you will install a differential air pressure sensor across the filter. Now, you can also monitor the door open if the, let's say, this air cooler, then if the door of that air cooler is open, you can also monitor. Okay. Now, flow switch, if that fan is delivering airflow, then overheat. Of course, it can also monitor the, if you are defrosting the cold room air coolers, okay? So if you are defrosting, so if it is overheat, then there are so many information here. Then analog output, input 1, analog input 2, okay, then analog output 1 and 2. Actually, this thermostat is capable of controlling two output devices. Like, let's say, if you have a solenoid valve for the refrigerant, then a heater or a valve for hot water. So it can also control the valve for the hot water and likewise for the refrigerant flow inside the, if there is a cooling coil there. Okay? Now, binary output, as you can see, we have here 6 binary output because this is capable of maybe your fan. Usually, the air cooler fans, it will come in a twin configuration. When I say twin, there will be, maybe there will be a duty and standby. Okay, so it can control two fans inside the air cooler. Maybe your fan is 3 speed. So output 1 is for the low speed, medium, and high for the first fan. Then this one is for low, medium, and high for the next or the standby fan. Okay. Then you can see also the activate schedule and so many information. Okay. Now, as a BMS engineer, your question is, do I need to display all of these things? No. The answer is definitely no. Because, as I said, as a BMS engineer, you need to study the specification. Let's say you will go to the air coolers material submittal. Then you will check the specification. What is being asked from these air coolers? Okay, so you will check. Okay, so these are the points stated in the IFC drawing or in this material schedule or equipment schedule. You can see there from the sequence of operation. Then you have to check what is being asked. Okay, now if you cannot see if you cannot see clearly what is being asked, then you can select. So as a BMS engineer, you know exactly or you know something what I need to display. Like if I'm the BMS engineer, I will say, okay, if there are two fans in an air cooler, then I will display the speed of the fans. So I can select these binary output 1, binary output 2, okay, up to 6. Then of course it is also a must to display also the analog output, especially the control for the solenoid valve and the control for uh, the control for the heat valve. Okay, if you have a hot water there. Okay. Now, actually, if it is a solenoid valve, it will be an open and closed control. Okay, it is not a modulating. Solenoid valve, it's just like a relay. If you will remember the relay, if you will give a supply to the coil, then that valve will open. If you remove the supply, the valve will close. It will depend on the valve, if it is normally closed or normally open. So you just make sure what is the valve, normally closed or normally open. Okay, so that is also a point that you need to check. Okay, then what else? Maybe this dirty filter, then door open. Okay, because these are also some important points. Maybe I can get 6 plus 2 plus maybe another, maybe max is 15 points. Okay, you can just select some other. Of course, you need to get the temperature set. So the temperature, okay, we will see if there is temperature. Okay, pressure. Okay, if you have a pressure sensor there. Internal temperature. I think this is the internal temperature. Okay, so these things or these values you need to display. Okay, then temperature set point. What is the set point for that air cooler? Okay, now Here, let me show you in my MSTP network. Okay, then the application. Now the application by default it will be empty. Now it will be your. Okay, let me go back here. I will just show you how are you going to transfer or copy some of the values. Okay, so again, let's say I want to copy this. All you need to do is click and drag it to the application. Now, as you can see, sometimes it will show you this it's not available or you cannot drag it there. Then wait for some second, it will become this plus. Okay, so meaning you can add it. Okay, so I will add it that one. Then let's say this one also. I will add this. Okay, now okay, then this one I will add this. Then this one I will add also. Okay, then let me see. Now this binary output, I will add also. Let's say we will add all these things now. Okay. Now let's see if we can do this. Okay, we will see if we can do that one. So that you will not do it one by one, but you will have to wait for some time. Okay. Okay. Then let's see. Okay, binary output. Did I think I already added the analog output. Okay. Anyway, I will go back later. Now let's get the some of the information here down below. Okay, temperature set point. I want this information to be displayed in my BMS. Okay, pressure. Okay, let's see. So internal. Okay, that's okay. For the time being, I think that will be enough. Well, I've seen some here. Control temp. Okay, let's just well, I think that will be more than enough. Okay. Now, so you should be consistent. Let's say you have around how many air coolers. So you have to use the same control and monitoring points for each air coolers. Okay. So now you need to create the next step is you need to create a simple graphics. Okay, so you have to create a simple graphics, then map or bind those points that you have selected to the graphics, then print out a graphics, then supply it should be included in your material submittals for BMS. Okay, so meaning if you will submit your material submittal, it should be included in your graphics proposed graphics for air coolers. Okay, then showing all the points that you will get from the third-party system. Now it should be approved by the consultant, so that during testing and commissioning, there will be no more question. If there is a question, what are these points? Is this approved? Yes, you have to show the approved material submittal. Okay. Now let's go to the application. Okay, so these are the points that I tried to get or copy from the thermostat. Now let's see some values. If we can see some, you can see some value here. Okay, so I've just added. Okay. Now open. So I have here close. Okay, one, two. Okay, so I have some control temperature is 25.78. This is the temperature that will be displayed in the thermostat itself. Okay, internal temperature. So this is the temp because I think I have there is a thermistor inside this thermostat. Okay, so it should be matching. Okay. Now temperature set point is 19.5. Now let me see if I will try to adjust. Okay, I will adjust the set point. That is 19.5. It is locked. The set point is locked. Okay, I will see how can I do the configuration in the thermostat, but it is locked. So 19.5 is the for cold room is not because in cold room the temperature is 0 or below negative. Okay, so these are the information that you can bind in your graphics. Okay, so air dirty filter, no. Okay, the value is no. Maybe you can configure also this one. Okay, it could be no or yes. Okay, anyway, actually you cannot configure this. You have to ask the supplier of the thermostat to reconfigure the thermostat, because all this thermostat, let's say you have uh, 24 air coolers. Now, as a BMS engineer, you need to specify exactly what is your requirement in the field, so that when you order this, you have to tell him, okay, maybe you can show him your graphics. Then you will tell me, okay, that I want these values, or the default values for this information being displayed in my graphics. Then they can reconfigure the thermostat before delivering it to the site. Okay, or maybe they will give you the capability of reconfiguring their thermostat if they don't want to send someone in the site to do it for you. Okay, anyway, okay, so I have here around 8, 9, 10, 11, 12, 13, 14. So 14 points. Okay. So I think this 14 points is more than enough to display the information from the air coolers. Okay. Now, the next thing that you need to do, as I said, create the graphics, because for the BMS operator, this is not very user friendly. So you have to create um, a simple graphics for air coolers. Maybe later I will create a simple one. Then I will show you how are you going to bind this. That could be part uh, 3 of this tutorial. Okay. So here, what you will do here, okay, you can do this download hosted objects. Okay, we will see. Now it will this system or my system will try to communicate. Okay. Now there is some warning there. If it is yellow, there will be some warning. Okay. Now, guys, since this is just a thermostat, it's not connected to the actual air coolers. Of course, you will be seeing some of a warning here. Okay. Then, okay. So this will be the information there. Okay. Sensor value 0 Pascal. Okay. So, guys, this is how you are going to do the initial software integration of a thermostat to your system. Okay, so let me repeat it. First step, do the field connection for your thermostat. Okay, just make sure providing the power and the communication will not be reversed. If you reverse it, then you have a big problem. You will fry all of your thermostat. Imagine if you have 100 thermostat, then you provide power in the communication. It will damage all those thermostat, and you might damage also your automation server. Now, it will be a very big catastrophe in your project. So be very careful. Okay. Now, go to the device discovery. Then, what is the device you need to discover? Obviously, it is a backnet device. Then it will be displayed under the network where you specify the RS485 and STP network. Then, if you have 100 or 20 uh, thermostat, then it will be automatically discovered. It will be displayed here. Okay, then one by one, you can go to a specific thermostat, then display all the information. Then in your MSTP network, you need also to uh, actually what you will do, you will drag one by one. Okay, so let me do it again. If you have here, let's say this is AC1, then you will be having here AC2, AC3, AC4. Then one by one, you have to drag it in your MSTP network. Okay, so when you drag it there, then it will be there. Okay, then one by one, you will try to select the points. Okay, now it will be a long process, especially if you have so many air coolers. Now, actually, guys, this one you have to really do uh, so many works if you're a BMS engineer, especially if the project is big. Okay, if it is small project, then there's no problem. It will be easy. But if it's a big project, imagine how many software integration that you need to do if it's a big project. in one of my projects, I have to do 13 software integration. I have to do software integration for BAB, VFD, variable frequency drive, MCCB, ACB, power monitoring units, generators, and so on. Okay, and there's UPS. So it is really a big task for a BMS engineer. Anyway, I'm just giving you an example of the scope of a BMS engineer. Okay, so I hope it is already a good head start for a new BMS engineer. Okay. Now the next part of this, I will try to create a simple graphics. Then we will try to bind it. Okay, so at least I have three parts of this thermostat. So again, guys, let me see. Let's try to look at the properties of this properties. Okay. So system operational, it should be operational, meaning the thermostat is in operation. Then the status should be online. Device change through, okay, no problem. Then what is important here is this operational and online. Database revision is 6, advanced. Okay, so this is the backnet name, that is default, okay. Device, okay, the object, so meaning 153101, this is the device ID of the backnet device. Okay, so this is the model TUBPS1. Okay, meaning there is pressure here. Vendor identifier and blah blah blah. Okay, so again, guys, this is the part 2 of my thermostat tutorial. Thank you very much for joining me, and I hope at least I am helping those new engineers and technical guys who want to join the field of building automation or building management system. So before I will end, thank you very much for watching. God bless us all. Let's all be safe and bye.